Now what is the field strength at a distance? D is asking. What are alpha and beta as it is a long rod? So alpha and beta tends to 90 degrees. Long, thin, charged rod. Or infinite long, thin, charged rod it is. How the E bar should be directed. Okay, let's substitute all these conditions here. Equal to K lambda D sine pi by 2 sine pi by 2 high cap K lambda D. Look at this quantity. This will be 0. So this will be, will end up with 2K lambda, 2K lambda high cap. Or further, K is what? K is 1 by 4 pi epsilon naught. So lambda by 2 pi epsilon naught D. What is small d? Perpendicular distance from the rod. And how the field will be directed perpendicular to the length of the rod. What is the type of field? Will it be uniform or non-uniform? I think we should have a basic idea. You are weaving from top. Suppose say this is a rod. Let's see this one. So now if I draw how the direction of field will be, the field will be directed radially outward. Yeah. It's not a point charge. The field will be radially outward. Why, sir, why you are showing the lines of force of this kind? As you move away from the rod, as the distance d increases, the electric field strength will decrease. And we know that field strength decreases, the spacing between lines of force should increase. That's all. So how the field will be similar to like a point charge where it's a top view. This is a rod. This one is a rod, charged rod. So till where the field will present? Till infinity. And as you move away from this, the field will keep on decrease here. This is very important. Means no, I'll draw a line parallel to the rod. What will be the field strength at all points on that rod will be equal to lambda by 2 pi epsilon naught d. Able to get this? This one. So you get so many numericals based on this, the lines of force. Means you should know how the field due to long rod. So what you should imagine now, the rod as some sort of like a black or red color. Surrounding it open yellow color, you should assume. So how can you make, shall we say like this will be cylindrical type? The field will be like some sort of a cylinder because a long rod, no? And what you should assume is a long rod, red color, long rod, you should assume. From that open, the yellow color is coming out, radially outward, along everywhere. This was the imagination one must have. Three-dimensional imagination one must have. Means like I have colors. Luckily, okay, we have a colors to show. I'll show it. This is a long rod. I'll bring a cylinder. So what is this cylinder? This cylinder is what? The lines of force. The field. Not finite everywhere. Till infinity, it will be spreading. So this rod will be there along its axis. No. Let me arrange a better one. This yellow color is not a rod. Yellow color is not a rod. The rod is this one. This is the charged rod. Everywhere you should assume And how the field will be radially outward. Okay, fine. This is the field. No thin rod, no question of inside the rod. No question of inside the rod. Huh? Let me have water. Okay, this is about the long rod. Next we'll go for semi-infinite rod. Semi-infinite rod. Let me bring this formula. Copy. What are alpha, beta? Okay, this is the alpha. And this is the D, no? So what is beta? Beta alpha tends to 90 degree. Beta will be 0. Okay, now please think over it now. Apply that formula. How to get the direction of field also. This formula will get everything for you. If you don't know this, again, you can integrate this also. You can solve by the same method. I think this will be, that approach will be, it's a bit very lengthy. Better if you remember this formula, it will help you to overcome all the situations, like whatever the type of question, you can easily manage. Okay, let's use this formula now. E bar is equal to K lambda by D sine pi by 2 plus sine 0 I cap K lambda D cos pi by 2 minus cos 0 J cap. So K lambda D I cap K lambda D minus J cap. Readily we got the answers. So it is having two components. One is, this is, will put it in a very simplified way, E perpendicular I cap E parallel J cap, because the orientation of rod can change. Rather than I cap J cap, we'll call perpendicular. So it will have one E perpendicular component, other will be E parallel. And what about that magnitudes? Both will be same. I really suggest you need not to, you can say goodbye to this formula now with this approach. For a finite or for a semi-infinite rod, there are two components will be there. One, E perpendicular. What is the E perpendicular? The component of field which will be directed perpendicular to length of the rod. What is E parallel? Component of field that will be directed parallel to the length of the rod. And what about those two magnitudes will be equal? How much K lambda by D or lambda by 4 pi epsilon naught D? So the resultant field, how much of what angle it can, how much of angle it must make an angle 45 degree, no doubt. Can we define that E bar? Already we have. For semi-infinite rod, okay, there's a condition. Okay, now same thing. Let me trouble you with. If the rod is oriented along x-axis, the rod is oriented along x-axis. No. Look at the, I want on the, this I'll put infinity. Here at point P, the electrostatic field is needed. Let me change symbol. Let me write A. Find field strength at point P due to semi-infinite rod where one end is at origin, the other end is at infinity, and the rod is along x-axis. This is a totally different problem. Let me control. Okay, now see this. What you are going to do? See, you need not to bother anything. Let me bring this point here. Now what you are going to do? There are two components will be there. No, one will be E perpendicular. The other component will be E parallel. Sir, how you are going to assume E perpendicular? Perpendicular to the rod. What about E parallel? Sir, why can't be like this? Why can't be E parallel? Now a student can think, sir, why can't E parallel? Say, go have some common sense. If there is a point charge is here, how the field at point P will be? Will be away from it, or will be in this direction, or will be in this direction? I don't want to talk much. The field at this point, how it will be? Will be in this direction, no? Or will it be like this? Or will it be like this? How will it be like this? You must answer it. 1, 2, 3, 4. Which one shall I pick up? The field at this point, due to this point charge, it should be away from, as it is a positively charged body, it should be away, no? In this direction. Then what happen? One component will be perpendicular, the other component will be parallel. So roughly you assume a small point charge. From there, what happen? You can make a guess of the resultant E bar along line joining the point charge to point P. Then one component perpendicular to the rod, other will be parallel to the rod. You should not do like this, huh? Sorry, E parallel to this. I'll put arrow like this. Then nobody can help you. Got the idea? So you should have assume a small elemental charge and get the direction of the approximate direction. Somewhere it will be like this. Then one component along y-axis, other will be along negative x-axis will come. Parallel means in any arbitrary direction you cannot put it. Okay, again, what are E parallel? E perpendicular lambda by 4 pi epsilon t. What is the total magnitude? Should be E perpendicular square, E parallel square. This should be the resultant field at point P. Magnitude. How much of angle it will make? It will make an angle 45 degrees. Okay. Because the magnitudes are equal, root 2 will come. 4 you can write 2 root 2. So finally this will be the magnitude. And it should make an angle 45 degrees. So rod need not be always along y-axis. The rod can be x-axis or any other thing. Even the rod can lie in some plane. I'll ask you to find out the field. Let's